Yes, I am Dr. Santosh Kumar Dwivedi, Professor in Department of Electronics and Communication Engineering. I will teach the subject Signals and Systems. Let me know what is signal. So, signal is very important for the communication. Without signal, communication is not possible. So, first, what is signal? So, signal is a function of independent variable like time, temperature, which conveys information from one station to another station. So, here the function. So, first we should know function. So, function may be continue or discontinue. As we know that according to the continuity of the function, the left hand side limit and the right hand side limit and the function value must be equal to each other, then any given function is known as the continuous function. If some break is there, it means function value, left hand side limit value, right hand side limit value. If anyone is not equal, then we can say discontinuous signal and you can say also discrete time signal. So there are the two types of signal. One is the continuous time signal and another one is the discrete time signal. Any signal will be represented in two dimensions, and in the two dimensions we have time and amplitude. This is the amplitude. This is the time. So on the basis of time and amplitude, signal again categorized into four parts. The one is the continuous in time, another one is the continuous in value. Second one is the continuous in value and discrete in time. Then continuous in time and discrete in value. Then we have both discrete in time and discrete in value. So first one, continuous in time and continuous value both. So see here, this function having a value for each instant of time. So we can say that time is continuous and its value is also continuous. And this type of signal is also known as the analog signal. Then second one, continuous in value but discrete in time. See, for each value of time here, this signal contains some value like 2. But for here, there is some break. So this break is showing the time is discontinuous. It means for this time there is no value for this signal. So you can say that continuous in value but discrete in time. Next one is the continuous in time and discrete in value. So this is used for the sampling theorem. Continuous time signal will be multiplied with the impulse signal. So we are getting some discrete signal. This is the discrete signal. So here the value is continuous, but here the time is the continuous, but value is the discrete. It means for this instant of time there is no value. For this instant of time there is no value. For this is but time is continuous. Value is discrete, discontinuous. So this is the continuous in time and discrete in value. Another one is the discrete in time and discrete in value. So here see, for discrete, each instant of time it contains no value. So this is the discrete in time and this is the discrete in value also. And it contains always 1. So discrete in time and discrete in value is known as the digital signal. So there are two types, the analog and digital signal. Very important for the computer communication and nowadays the mobile communication also. derive the transfer function for a given system. So according to the convolution, we can find out of y of t is equal to x of t convert by the h of t. Taking Fourier transform of both sides, so we will get Fourier transform of yt. This is equal to Fourier transform of xt convolution by st. So this is equal to y of j omega is equal to h of j omega into x of j omega. This is the multiplication property of the Fourier transform. This is the convolution property of the Fourier transform. So h of j omega is equal to y of j omega upon x of j omega. This is the transfer function of a system. So the transfer function of a system is defined as the Fourier transform of the output in time domain divided by the Fourier transform of the input in time domain. So h of j omega is equal to y of j omega divided by x of j omega. This is the transfer function of a given system. And